Bismillahirrahmanirrahim. Dear students, today I come up with question number 7 of your chapter triangles. This is the chapter which is related with class 10 subject mathematics. Dear students, the question is written as the diagonals of a quadrilateral ABCD intersect each other at point O such that AO upon BO is equal to CO upon DO and show that ABCD is a trapezium. Dear students, in order to understand the question, let's make a figure. And the figure should be like your trapezium. Here, let us denote its vertices as A, B, C, and D. Then we will draw the diagonals. Let us have AC is one diagonal and DB is the another diagonal. As it is written as the diagonals of a quadrilateral ABCD, it is intersect at point O. Let us have this the intersecting point, and it intersects at point O. And it is given that AO upon BO is equal to CO upon DO, and what we have to show this whole figure is a trapezium. Dear students, we will write it as in solution. The given is here ABCD, a quadrilateral is given, rather we can say a quadrilateral is having vertices ABCD whose diagonals like AC and BD intersects at point O such that AO upon BO is equal to CO upon DO. Dear students, this is the given of the question, and what we have to prove, we will write it as we have to prove ABCD is a trapezium. In order to prove it, let's go for construction and construct here a parallel. OE is parallel to AB. Let's take it as. In construction, we will draw line OE that is parallel to AB. Dear students, now we will take this triangle like this, that is having A, B, and D, and in a triangle we are having now a line, and that is denoted with OE, and this OE by construction we draw it parallel to AB. So once in a triangle a line is parallel to the either of the side of a triangle, the sides will be divided in the same ratio as per BPT. So we will write it as in triangle. In proof, first of all, in triangle ABD, OE it is parallel to AB. How? By construction. We'll write it as by construction. So one such situation happens in a triangle. What happens to the triangle? The sides of the triangle will be divided in the same ratio from the common vertex. Here D is the common vertex, so we will write it as DE upon EA is parallel to DO upon OB. Mark it as first and write here by BPT, basic proportional theorem. And thereafter it is also given, we will use this given here. It is given that AO upon BO is equal to CO upon DO. Dear students, here we are having DO upon OB, or I will write it as BO here for convenience. So we will change here, go for changing like this. We will write AO and DO, they are in multiplication, so we will write DO upon BO. We will shift this AO here and DO here. In this side, CO upon BO. in order to make these two sides equal, now mark it as second. By comparing first and second, we get, once these two sides are equal, it means the rest of the two sides are also equal. That is, DE upon EA is equal to CO upon BO. So DE upon EA is equal to CO upon BO. It means this triangle is now involved here. Here we had DO upon BO. Once we change DO here, we will write AO here. So it is AO. So it means DE upon EA is equal to CO upon OA. It means this way the triangle is now involved. So such situations have, once the sides are divided in the same ratio, it means this OE, it is parallel to DC also. OE, it is parallel to DC. How? By converse of BPT. Converse of BPT. With the help of converse of BPT, we'll write OE is parallel to DC. But earlier, this OE, it was parallel to AB. It means, dear students, that EO or OE, it is parallel to BA. So DC is parallel to AB. Once OE is parallel to DC, OE is parallel to DC. Once it is parallel, OE is parallel to AB. It means AB is parallel to DC. So in conclusion, we will write AB in ABCD. This DC side, it is parallel to AB side. So in a quadrilateral, if two opposite sides are parallel while the two other sides are not parallel, so ABCD is a trapezium. Hence we will write it as, hence ABCD is a trapezium. Hope you understand it very well. Thank you.